Welcome. My name is Mohammed Al Kailani, presenting to you today the opportunities and challenges for adoption of photovoltaic panels on community level at Andalusia compound in Amman, Jordan. Aim of the study. The study aims to examine the implementation of solar power system on residential community level and identify potential barriers that might face the system from stakeholders' perspective. Study objectives. Select and study infrastructure systems of an existing residential community. Identify an environmental challenge facing the community's infrastructure systems and propose a solution to improve its sustainable performance. Collect data to identify potential barriers from stakeholders' point of view. Propose an optimal scenario that improves the opportunities to apply the system, taking into consideration stakeholders' concerns. Methodology. For Objective 1, use data available in public domain and contacts to select the case study community. For Objective 2, infrastructure system is given by the module instructor. Objective 3 uses mixed method approach using interviews and survey to know the stakeholders' opinion regarding the proposed infrastructure system. Objective 4 performs statistical analysis of the collected data to derive optimal strategy application scenario. Community selected is Andalusia community in Amman, Jordan. The system selected is photovoltaic panels. Introduction. The infrastructure of a city consists of the basic facilities such as transport, communications, power supplies, and buildings which enable it to function. There are two types of infrastructure. The first type is hard infrastructure, such as roads, bridges, power stations. Second type of infrastructure is the soft infrastructure, such as education, financial, and legal systems. Electricity is an essential part of modern life and important to economy. People use electricity in every aspect of life for lighting, heating, cooling, operating appliances, transportation systems, and industry. Majority of electrical power is produced through burning of fossil fuel, causing pollution and many other harms to life and to environment. Solar energy is the largest source of energy found on Earth, transmitted in the form of heat and light. Solar energy can be used to produce electricity through technologies like concentrated solar power (CSP) or photovoltaic PV cells. This study is concerned with the second technology, photovoltaic panels. This study assumes a grid-connected PV system that consists of PV panels, inverter to convert DC power to AC power, net metering using bidirectional counter through which extra energy generated by PV panels is fed back to the grid, and by the end of term, the net consumption value is built. Here are some basic facts about the case study community Andalusia in Amman, Jordan. Located in the southern outskirts of Amman, capital of Jordan, near the historical city of Madaba, and towards the direction of Queen Alia International Airport. The community occupies an area of 776,684 square meters, consists of 588 villas, a health club, swimming pool, shopping center, and public parks. The total investment made is $211 million. There is within the community an empty plot of land that can be used to install PV panels to provide power for common facilities. PV panels will be distributed into two sections. The first section that provides power to villas will be installed on top roof of each villa to reduce the maintenance and correctly allocate electricity cost based on each individual villa consumption. Second section that provides power for common facilities like street lighting, security, irrigation system, etc., will be placed in the empty plot. Communities' existing hard infrastructure systems. National grid power. Some houses use PV panels, partially connected to the national drinking water system, artesian well, sewage system, grey water recycling system, roads and streets lighting, green areas with irrigation system, common building, club, swimming pool, shops, etc. Average temperature and precipitation rate in Jordan shows that the climate falls between Mediterranean and desert climate. Average temperature during winter is between 9 to 13 degrees Celsius. Summer temperature average between 26 to 29 degrees Celsius in the heights and 39 degrees Celsius in Jordan Valley. July is the sunniest month of the year, while December has the lowest sunshine. The average annual sunny days in Jordan is around 300 days. Jordan falls within the world's solar power belt in the good areas that are appropriate for solar power plants. Amman's global horizontal irradiance (GHI) is around 2,200 kilowatt-hour per square meter, making potential annual yield for typical PV system 1,970 kilowatt-hour per kilowatt peak. To assess potential economics of the PV system, a simulation performed using Homer software. Jordan's electricity price as of May 2022. Category A 7 US cent per kilowatt hour, Category B 14 US cent per kilowatt hour, Category C 28 US cent per kilowatt hour. Cost of electricity considered in the simulation is Category C after examination of several villa electricity net consumption found over 600 kilowatt hour even with PV system installed. Homer schematic shows system components as PV panels, converter, and power grid. PV panel estimated cost is $500 based on the current market rates. System lifetime 15 years. Converter cost estimated as $2,500. A grid kilowatt hour cost is US cent 28. Net excess kilowatt is US cent 20. Homer simulation result showing payback period is 2.3 years, return on investment 36.5 annually, and average leveled cost of electricity 5 cents per kilowatt hour. The total initial investment cost is around $5.3 million. Quantitative data collection survey. A stakeholder survey was conducted that is completed by 36 respondents. Several variables shown on the screen are measured and analyzed using descriptive and inferential statistical analysis methods to derive the required results. 40% of the respondents are satisfied with living in this community, and 20% are very satisfied. 40% of respondents are neutral towards their satisfaction about current infrastructure systems, while 20% are unsatisfied, making satisfaction mean 2.7 out of 5. One-way ANOVA test shows a significant evidence that admin issues affect the service availability while financial issues are insignificant. Current average monthly cost of electricity paid by the respondents shows to be between $1,000 to $2,000. 96% of the respondents accept to install PV panels on their house roof. One-way ANOVA performed at significance level of 5% shows a significant effect caused by monthly cost of electricity on the residents' acceptance to install PV systems. The main challenge identified by the respondents was the initial cost. Independent sample t-test performed shows no significant evidence supports that the residents who accepted to install the system for common facilities are willing to make monthly installments. Residents prefer to have an incentive scheme like reduction of annual service fees to encourage the adoption of PV system to generate electricity for common infrastructure services. Semi-structured interviews with stakeholders. Total of 6 interviews conducted with different stakeholders, and the responses analyzed based on their content. Summary of answers to interview questions. Specialization and job role. Variety of specializations interviewed like electrical engineer, technicians, and administrators. Regarding their experience in PV system, 4 out of 6 interviewees had previous experience. Their point of view on the efficiency of PV systems. Most of the interviewees confirmed that PV panels can perform well if the components are of good quality and the system was well maintained. Potential challenges to the system from their point of view was initial cost as the main challenge, while 2 of the interviewees referred to administration challenges. Their opinion on the community's acceptance of the system, 3 out of 6 interviewees confirmed that reduction in annual service fee can encourage the system adoption. Conclusions. The use of PV panel system in the Andalusia community reduces the leveled cost of electricity by 28% up to 82% depending on the consumption segment. The system payback period is relatively short, 2.3 years. Administration challenges prevent utilization of some of existing shared infrastructure systems like artesian well and water treatment plant. 96% of the residents accept to install PV panels on their house roof driven by the current high cost of electricity. The main challenge to the adoption of the system on community level is the initial cost and administrative difficulties. Stakeholders provided that an incentive scheme include reduction of annual service fee may encourage more residents to accept the implementation of the system. Thank you for your time.